Hi everyone, this is Janine aka Janine The Tutor. Welcome back. If you've watched some of my previous live classes, so I know now is a very difficult time for everyone, and the last thing that's probably on your mind right now is to learn math. So hopefully, you take my classes, and at the end of this class, you'll pick up a thing or two. So for today's class, I will be going over the popular questions that we've received on homework help on OneClass. So at the end of the day, we just want to express our gratitude for being able to adapt to the circumstance quickly, and that's why we want to help you students stay on top of your studies. So let's get started. Before anything else, I just wanted to make sure you can hear me coming through and you can see my screen. So you should be seeing two panels. The question is on the left side of your screen, and you have this whiteboard over here. Great. So for the first question, it says which polynomial function has a leading coefficient of 1 and roots 2i and 3i with multiplicity of 1? Okay, so what I'm going to do is I'll read through the solutions that they presented on homework help, and I'll verify through whether it's right or wrong and give you some of my tricks. Okay, so they're saying that to find a polynomial expression having 2i and 3i, and by the way, what are this I behind 3 and 2? So these are what you call imaginary numbers. So if you recall, we have real numbers and imaginary numbers. So for complex roots, so say for example, you're looking at x squared plus 4 and x squared plus 9, you can't really factor them out, right? Because in this case, if you have x squared plus 4, so maybe I can show you that. Okay, so if you have x squared plus 4, right, you can't really factor this because even if you have, let's say, x squared plus 4 is equal to 0, if you move that 4 to the opposite side of the equation, and this is very similar to x squared plus 9, you're going to see that this is a negative number and you cannot take a square root of a negative number. So that's why it's important to be able to have imaginary numbers for you to be able to have this x minus 2i and you have x plus 2i. So that's the reason why. And if you take a look at, let's see. Okay, so coefficient of 1 and roots 2i and 3i with multiplicity of 1. So when they say multiplicity of 1, what that means is if you have, for example, a function y is equal to x plus 2, right? And let's say you have x minus 4 squared, right? So if you take a look at individual terms, say for example x plus 2, if your exponent is raised to the power of 1, that means it's a multiplicity of 1. However, if you look at x minus 4 squared, because it's squared, therefore your multiplicity is squared. And if we're looking at degree, just so you know, because multiplicity and degree is typically learned at the same time. So if you look at this function, x plus 2 times x minus 4 squared, the degree is going to be 3, right? Because it's multiplicity of 1 and you have a multiplicity of 2, therefore the degree is 3. So yeah, that's for multiplicity and degree. And because you want to be able to factor this, right? Polynomial function x squared plus 4 and you have x squared plus 9. In that case, when you write x squared plus 4 in terms of imaginary numbers, it would be x minus 2i and x plus 2i. And then when you're looking at x squared plus 9 in terms of imaginary numbers, it would be x minus 3i and x plus 3i. So that's why, let's see. Which polynomial function has a leading coefficient of 1? And apparently they don't really write out our options. We don't have the options over here, so we can't really see what the other polynomial functions look like. So if you were to, I guess, match this, if you have this polynomial, then that means that would be x squared plus 4 and you have x squared plus 9. And in addition, as you can see, they're trying to specify what exactly a polynomial function is. So a polynomial function, as you can see, you have an, then you have xn. So this is just a formula, a general formula for you to follow, and you have real numbers 0 to n, right? And it says if you have degree n, that n would not be equal to 0. So when they say, for example, here, right, let's see. Yeah, so this n over here, because I know there is an an. So an is basically your leading coefficient in a polynomial function. That's just terminology. And then if you have, let's say, n over here, if this is not equal to 0, so let's say this was 3, then therefore it's a cubic function, and your degree is going to be 3. So it's the highest power, basically, in a polynomial function. So yeah, this is your term, right? And within your term, you have what you call your degree. So the degree would be the highest power, and you have this number, which is a constant. So an is a constant that is multiplied to your x raised to the power of n. So let's say x raised to the power of 3. Therefore, an is going to be your leading coefficient because it's the constant that is multiplied to the highest power of x. So that's what a leading coefficient is. And then they're trying to look at complex roots. So this is just how we write complex roots. So typically you would see a plus bi or a minus bi. And in this case, they've used p plus iq or qi. So this is just a way to factor complex roots. And how did they arrive to this conclusion that it's x raised to the power 4 plus 13x squared plus 36 is equal to this? You just need to apply the FOIL method. You probably know this by now. So this is x squared plus 4, then this is x squared plus 9. So all you have to do is look at your outer function. So you have this, which is going to be x raised to the power of 4, right? You multiply x squared times x squared, and then subsequently, you're going to have x squared plus 9. Sorry, x squared times positive 9, so that's going to be plus 9x squared, and then afterwards you're going to have 4 times x squared, so that's going to be plus 4x squared, and then from there you can see that you can multiply 4 times 9, which is just going to be 36, right? And why is this 13x squared? Because you've combined 9 plus 4, right? So 9x squared plus 4x squared is going to be 13x squared, and you have plus 36, and this is basically x raised to the power 4. So yeah, your degree is going to be 4, right? Leading coefficient is 1 because it's multiplied to the highest power of x, and let's see. Yeah, the multiplicity of x squared plus 4 is going to be 1, and the multiplicity of x squared plus 9 is going to be 1. So this is your polynomial function, and it's absolutely right. So okay, so the solution is correct. Great. So next question we have, in which quadrant is the number 6 minus 8i located on the complex plane? Okay, so I know this may sound really overwhelming just by looking at the question, but honestly, if you remember your coordinates, right? So let's take a look at your x and y axis. So this is your y-axis and this is your x-axis, right? So what they're trying to do here is they're trying to break down your x and y coordinates. So if you have your 6 over here, they're going to write this as 6. So that's going to be your x coordinate, and your y coordinate is simply going to be the number that is multiplied to your imaginary number. And in this case, it's going to be minus 8, right? So this is going to be 6 comma negative 8, right? So typically when we're learning this, right, back in middle school, if we try to look at coordinates, this means your x is going to be 6, and then your y is going to be negative 8, right? So all we have to do is really plot that over here. And as you can see, in which quadrant is the number 6, negative 8i located on the complex plane? It's going to be found in quadrant 4, right? It's simple as that. All you have to do is extract. So here we see that if this number is multiplied to your I, it becomes your y coordinate, and if you look at 6, that's going to be your x coordinate. So anything that is multiplied to I, that becomes your y coordinate. So that's why this is found in quadrant 4. Okay, so I don't think this is really that hard. Okay, let's see what they wrote. Okay, so we have a comma b, that's what they did, and that's what we did. And then you have the complex number 6 minus 8i, point in the complex plane would be 6 comma negative 8, exactly what we did. let's see, the point 6 comma negative 8 will lie in the fourth quadrant because the value of x is a positive real number and the value of y, okay, yeah, it's pretty much what we did. So perfect solution and answer. Okay, great. So the solution is correct. Okay, so here's the thing with taking the square root of 90. So this is a question where we need to take the square root. So what is the square root of 90? Simplified in radical form. The thing that I notice on homework help is they have this huge solution, basically. And they're saying that this is going to be positive or minus 9.48. So what I've noticed is you're not really supposed to write your square root of 90 in terms of a decimal number, because typically for teachers, I noticed that they want you to express your answer in radical form, and that's what the question is asking you, right? What is the square root of 90 simplified in radical form? So therefore, you need to express your answer in terms of radicals, not in the decimal form. Okay, so this is what I do. This is the easiest way to do it. So if you take 90, right, you're going to apply synthetic division and then you're going to simply divide your number. So it could be anything, right? It doesn't need to be 90. You're going to think of prime numbers, right, such as 2, 3. So easy numbers that doesn't really have any other factors except itself and 1, right? So as you can see, we know that 90 is an even number, therefore it's divisible by 2. That means you can divide 90 with 2 and get an exact result without any remainder, right? So if you have 90 divided by 2, that's going to be equal to 45, right? And right off the bat, I can see that 45 ends in a 5, right? Any number that is divisible by 5 is going to be either ending in 0 or 5, right? So 45 divided by 5 is going to give me 9. And then from there, I can see that 9 is divisible by 3, therefore 9 can be divided by 3 and you get 3. So what I'm trying to say here is you need to make sure that when you're dividing, it's going to be in terms of prime numbers. And the reason for that is because it's easier to group numbers if they're expressed in prime numbers as opposed to like 10 and you have 2, then you have like 5, right? So just by looking at prime numbers, you can see that they're being grouped together in terms of a pair. And the reason why it's a pair is because you're taking the square root. And why is it a pair of numbers is because if you look at a square root, the index of, let's say here, of like 90, that's what we're trying to look for, is going to be 2, right? That's why we pair the numbers as opposed to grouping them by 3, right? Because if this was a 3, if this was a cube root, therefore you're supposed to you're supposed to group the numbers based on 3 numbers in one group. Does that make sense? Okay, so that's why when you're taking the cube root, right, instead of grouping numbers based on 2's, it's going to be 3 numbers. So you need to have another 3 over here to group them into 3. So yeah, so you do synthetic division and then you have to divide this with prime numbers because it's easier to group them. And then once you see that, you're going to have square root of 90 and then you just basically have 2. So replacing 90 with 2 times 5 times 3 times 3, and you see right off the bat this is basically square root of 9, right? 3 times 3 square root of 9. So all you do is you take out or you factor out 3, right? Because that's square root of 9. Square root of 9 is equal to 3, and what's left inside is going to be 10. So that's why your final answer is going to be 3 square root of 10, and don't forget you still have the plus or minus because you're taking the square root of a number. So great. Yeah, even if you type this into your calculator, you're going to see that the radical form is going to be plus or minus 3 square root of 10. So yeah, I don't think this is even necessary. You just have to apply synthetic division and basically factor, not factor, but divide the numbers based on prime numbers. Okay, great. So, and as you can see, they gave a couple of examples below. Again, they're looking for the simplified radical, so it's not supposed to be expressed in decimal form. Okay, so solution is incorrect and answer is incorrect. Actually, solution and answer are incorrect. The square root of 90 is equal to, okay, let me try to look for the plus and minus. And let me just copy that. Great. Is equal to plus or minus 3, and you have square root of 10. Okay, because we're in this symbol, okay, square root symbol. Yeah, I think it's just easier to read, so we're just gonna copy this symbol. Okay, 3 square root of 10. We must express our answer in terms of a simplified radical, as the question states, not in terms of decimal. Okay, solution is incorrect for this one because we're supposed to express this in radical form. Okay, so here's the thing with finding the square root of 6 in simplest radical form. As you can see, if you apply the synthetic division as I've told you, right? If you find prime numbers that can be divisible by 6, you're going to see that it's only going to be 2 and 3, right? So regardless, you're going to have 6 divided by 2, which is going to give you 3. And you can't really group the numbers. That's why the final answer is still going to be plus or minus square root of 6. So, and let's see what they wrote. So the square root of a number can only be found, this should be found, if that number is divisible by perfect square other than 1. A 6 is divisible by perfect square, so square root of 6 cannot be simplified further, so this is right. Square root of 6 cannot be simplified further. In contrary, square root of 12 can be simplified because, okay, so I know they're trying to say more information for the following, but this is not even relevant to answer the question. So, but what they're trying to say here is if you take the square root of 12, it can be simplified. Okay, so let's take a look at 12. Okay, so when you write or when you apply synthetic division to 12, you're going to see that 12 is divisible by 2, so that's what we're going to do. So 12 divided by 2 is going to be 6, right? Divided by 2, you're going to see that this is 3. So in fact, you can pair the numbers, right? You can have in one group 2 of your 2's, right? So in that case, you're going to say that, okay, so I have 12, so this is 2 times 2 times 3. So this square root of 2, sorry, square root of 4 rather, because it's 2 times 2, is actually going to be 2, right? Because if you take the square root of 4, it's going to be 2, so this is just going to be plus or minus 2, and whatever's left inside is going to be square root of 3. So that's why what they're trying to say here is, in contrary, square root of 12 is going to be equal to this. Yeah, okay. And then square root of 250. Okay, let's take a look at that. Again, anytime you're trying to answer a question, even on the test, this is something that we can learn from homework help. Focus on the question. Don't try to bring in things that are not going to answer the question, because I think a lot of students, especially for short answers, they have a tendency to go overboard, which doesn't really answer the question. So yeah, this is something that we can learn from homework help. So if you have square root of 250, right? Like, it's good to have examples, I guess, for this portal, but when you're writing the test, keep it concise and answer the question. Great, so we have square root of 250, right? We apply synthetic division. We're going to have 250. As you can see, it's an even number, therefore it's divisible by 2, right? So 250 divided by 2 is going to be 125. 125 ends in a 5, therefore it's divisible by 5. So if you have 125 divided by 5, you're going to get 25. So this is 25, and 25 divided by 5 is going to be 5. So as you can see, you can actually write square root of 250 in terms of square root of 2 times 5 times 5 times 5. So there's 3 5s within that square root. You can group this, right? Square root of 25 is going to be 5. So you can actually have 5 outside, and this is plus or minus 5, and whatever's left inside is going to be 2 times 5, which is 10. Therefore, it's going to be the square root of 10. So square root of 250 can be written as plus or minus 5 square root of 10. So that's going to be your final answer. And because it is also divisible by a perfect square like 25, yes, it's divisible by 5, right? That's why we have this 25. Okay, but that's the whole point with square root. So apply synthetic division and then divide your number with prime numbers and then pair the numbers. That's my tip for taking the square root without a calculator. Okay, so they pretty much said you can't really simplify square root of 6, so I'm just gonna commend them for doing that. So perfect solution and answer. Okay, so what is 66 and 2 over 3 as a fraction in simplest terms? Okay, so throw back to middle school. If you have a mixed number, so this is 66 and you have 2 over 3, right? Typically when you're trying to simplify fractions, it's easier when they're in if you want to simplify fractions, right? It's easier for you to simplify them when they're expressed in improper fractions or you only have a numerator and a denominator. Because in here, you do have a whole number, right? Because that's why it's called a mixed number, right? It's because you have a fraction and you have a whole number. So maybe we can express this in terms of just a fraction. So you would have to multiply 3 times 66, right? So 66 times 3, and then you need to add that to 2, right? So that's plus 2 to give you your new numerator. So this is just going to be 200, right? So how do I get 200 again? I have to multiply 3 times the whole number, 66, plus 2, I get 200. So that's my new numerator. And then for my denominator, whatever is coming from the mixed number, that's just going to be the same thing. So it's going to be 200 over 3. So as you can see, you cannot simplify 203, or in other words, there's no other number that is divisible to both except 1. Therefore, you cannot simplify 200 over 3 even further. So that's why, yeah, in simplest terms, you can even say that this is simplified already or 200 over 3. So let's see what they wrote. Okay, so they're trying to say that in order for you to write a mixed number into fraction form, we first need to see what the denominator is to see what proportion it divides the number into. In this case, the denominator is 3, and this tells us that the number we need to find is divided into thirds and has a remainder of 2 over 3. Okay, so in my opinion, just multiply this, add this to 2, you get the numerator. Simple as that. Then it says, so we have 66 whole parts and 2 over 3 of a whole part. Now we need to find which number when divided by 3 equals 66. Okay, so they're pretty much trying to do 198 divided by 3. Again, there's going to be multiple ways to find the improper fraction, but because you want to make sure you're as efficient as possible, pick any method that works for you. So, but this is still right, 200 over 3. So okay, so solution is correct, and as well as the answer. Great, so let's move on to simplifying fractions. So we have 1 over 3, and this is basically multiplied to 9 cubed, right? So typically what I tell my students is either to expand 9 raised to the power of 3, or you can write 9 raised to the power of 3 in terms of the base 3 instead of 9, right? So I guess we can have two options. So option A is going to be you expand, so you have 1 over 3, then you multiply this to 9 cubed. So 9 cubed, when you expand that, that's going to be equal to 729. So 729 is 9 cubed. So 729 divided by 3 or times 1 over 3, this is going to be 243. So this is option A. Option B is to express 9 cubed, right? So 9 cubed is going to be expressed this way. So you have 3 and this is going to be squared, right? And why is it 3 squared? Because it's 9, right? And then on top of that, you have this 3 as a power, right? So what you do is you take 1 over 3 and then because based on exponent laws, you're supposed to multiply 2 times 3, right? So you're going to have 3 raised to the power of 6, right? And then from there, you're going to simplify your bases, right? And your exponents. So as you can see, you have a 6 here, and this is basically raised to the power of 1. So that's going to be 3, right? And this is going to be raised to the power of 5, right? Which is 243. And how do I get 5? Anytime you're trying to simplify exponents, right? With the same base, right? So in this case, you have, let's see, yeah, so you have 3 over here. So this is raised to the power of 1, right? So in that case, all you have to do is take 6, then you subtract 1, so you get 5. And your 3 goes on top, which is on your numerator. It's because you have a higher power, which is 6, right? So that's why it's 5. So this is 243. Or you can write this as -1, then you have 3, then you have 6. Then all you have to do, because you're multiplying, right? You're supposed to add your exponents. So this is 6 and -1, it's still going to be 5. So this is 243. Okay, great. I think I've covered everything that I wanted to talk about. Really, it's up to you for your preference, based on your preference. So if you prefer this, go ahead and use that. If you prefer this, it's up to you. So okay, so perfect solution and answer. And I think they went and expanded the terms, which is option A. So it's up to you. Okay, great. So let's move on to this question. So it says ray CE is the angle bisector of angle ACD. Which statement about the figure must be true? Okay, so let's take a look at this. So first of all, they're saying you have a ray which is CE, right? And what is a ray to begin with? So a ray is basically you have a point and then it extends in one direction. So that's what a ray is. So you have ray CE and it says it's the angle bisector of ACD. So angle bisector is basically it creates angles, right? That's why it's called an angle bisector. It creates an angle on top of bisecting ACD. So right off the bat, you can actually see that it should be option D. That's true because if you look at ACD, and because it's an angle bisector, right, you're supposed to have two equal angles. That's why you have ACE, and that's twice of that because you can actually say that ECD, right, is going to be equal to ACE or ACE, right, angle ACE. So that's why it's twice of that. And let's take a look at ACE. So let's take a look at option C. So option C, it says angle ACE. So ACE is going to be equal to DCB. Well, you can't really attest to that just because you don't really know what this angle dimension is. So this is incorrect. So for part C, this is out of the way. If you look at option B, it says you have angle ECD. So ECD is over here, so this is like the blue angle. And you have angle ACD. Obviously they're not equal to one another, right? So you cannot say that. And then if you look at angle A, it's angle ECD. So that's over here, and then you have ECB. They're not equal to one another, right? Because ECB is larger compared to ECD, right? So that's why it's going to be option D. That's right. Okay, so they're trying to give you a couple of dimensions, which is 40 degrees, then you have the straight angle, which is 180 degrees. I don't think it's needed to answer the question, just because by definition we know what an angle bisector does. That's why you don't really need to introduce dimensions or measurements of angles. So, but for option A, yeah, I think it's just easier for students to visualize that if you do have numbers. But again, you don't really need to answer this question using measurements of angles. Okay, so let's just take a look. Option C, they said it's 40 degrees. You have 100. Okay, so they're saying option D is correct, and they're saying since CE bisects angle ACD, therefore angle ACE is equal to angle ECD, and then you have ACE plus ECD. So ACE plus ECD is going to be ACD. That's true. So yeah, that's why it's twice of angle ACE. So perfect solution and answer. So the solution is correct, so great. Next question, it says which is the only center point that lies on the edge. Okay, let me read that one more time. Which is the only center point that lies on the edge of a triangle? So, if you think about triangles, right, it could be right triangles, it could be acute triangles, it can also be obtuse triangles, right? Anytime you look at, okay, so in this figure, they're looking at triangle ACE, right? It's a right triangle. Anytime you have a right triangle, if you have a circumcenter, right, that means you have a circle that is outside and you have your triangle inside, right? So if you have a circumcenter, that means it creates a midpoint, right, in your hypotenuse, right, of your right triangle. So that's something that you need to remember. It's basically your concurrency where your triangle is going to have perpendicular lines, right? Or a perpendicular bisector. That's why they don't really show you where the circle is, but the circle is over here, right? And you have a circumcenter, so that's the center of your circle, and this creates your concurrency where you have perpendicular bisectors. So basically this is one perpendicular bisector, this is another one, and then there's another one. So there's 3 in total for right triangles. And on top of that, if you have a circumcenter and it's a right triangle, that creates a midpoint in your hypotenuse. So that's something that you need to know, which is the only center point that lies on the edge of a triangle, and circumcenter is the only center point on the edge of a triangle. Yes, that's correct. This is true in the case of a right angle triangle. It exactly lies on the midpoint of the hypotenuse. Okay, so they hit the mark. They mentioned midpoint, they mentioned hypotenuse, they also mentioned it's the point of intersection of the perpendicular bisector sides of triangles. And they also hit the mark where they specified you create perpendicular bisectors. So, perfect explanation. So yeah, I have nothing to correct because they actually mentioned 3 items that I was looking for, or 3 main points that I was looking for, so great. Okay, so moving on to inequalities. It says which number line represents the solution set for the inequality -4 times x plus 3 less than or equal to -2 minus 2x. Okay, so anytime you're dealing with inequalities, right, you're going to treat them like an equation. So if you have -4, so let's start by writing -4 times x plus 3, and this is basically less than or equal to -2 minus 2x. So really, remember when we're trying to solve for x in an equation, you just have to isolate for x, and then basically everything just follows, right? You have to either divide both sides with a number, right? So in this case, as you can see, we need to isolate for x, right? Sorry, we need to isolate x. Therefore, in this case, we need to distribute -4 to x and to +3, right? So it's very similar to solving equations when you're isolating x, right? So in this case, you would have negative 4x, and this is going to be minus 12. So it's negative 4 times x, that becomes negative 4x. And then because you have negative 4 times positive 3, that becomes negative 12. And then you have less than or equal to negative 2 minus 2x. So you know that this is negative 4 and this is negative 2x. So basically there's like terms, right? So I can just move this negative 2x to the opposite side of the equation. So I get negative 4x, and this is plus 2x, right? So that is going to be, so negative 4, and this is plus 2, right? So that's going to be negative 2x on the left-hand side. And then basically you're still going to copy this less than or equal to, and then this moves to the opposite side. So this becomes positive 12. So 12 minus 2 is going to be 10. Dividing both sides with negative 2, right? And this is something that you need to remember by now. If not, drill this into your head. If you have negative 2x, right, or any coefficient, if you're dividing an inequality with a negative number that's coming from this side of your equation, so that's the coefficient, right? So if you're dividing your inequality with a negative coefficient, right, it doesn't mean that this needs to be negative, okay? So I'm just talking about the coefficient. If you're dividing your inequality with a negative coefficient, you need to remember to flip the sign of your inequality. So if this was less than or equal to, now this becomes x greater than or equal to, and this becomes negative 5. And the reason why we had to flip this is because this was negative 2. You're dividing both sides with negative 2. So that's why this is going to be negative 5, and it says it's included. So we shade that over here, right? And basically this is going to be greater than, so it's after negative 5 in our number line. So this is, as you can see, the graph. And this is true, so perfect solution and answer. So the solution is correct. Great, so which function has only one x-intercept at negative 6, 0? Okay, right off the bat, you can actually see that it's going to be number 3. And let me just explain why it's going to be number 3 by starting off with option 3. Okay, so you have a function which is f of x, and this is going to be x plus 6 cubed, right? So what I'm trying to say here is if you want to have just one x-intercept at negative 6, 0, that means you're going to have negative 6 as your x, right? And then you have 0 as your y. So when you're trying to find your x-intercept, right, you're going to have 0 plug in your y, because we know that f of x is also the same thing as saying this is y, right? So this is just y, and then you're solving for x plus 6, and this is cube, right? So let's see. Yeah, so they did exactly what we have here. So this is x plus 6, and this is cubed, and that's equal to 0. And how do you even solve for x, right? You have a cube here. Well, all you have to do is you take the cube root, right? Because if you take the cube root, right, you know that taking a cube root gives you an exponent of 1 over 3, right? Or you can say this is x plus 6, then you have cube, and this is raised to the power of 1 over 3. And if you have a power, right, raising to another power, all you have to do is multiply the 2. That's why you get 1, right? So that's why we take the cube root of 0, and that's just 0, right? And from there, this gives us x plus 6, right? Because 3 times 1 over 3 is going to be 1, right? So from there, we can say this is just x plus 6, and this is equal to 0. So if you move positive 6 to the opposite side of the equation, you get negative 6, which is x. And that's why your x-intercept is just going to be negative 6, 0. And then if you look at option A, right, so for option A, they're saying that, or actually option 1 rather, for option 1, they're saying this is f of x, which is equal to x squared, and this is x plus 6, right? So right off the bat, any x-intercepts that you have, this is basically a 0, right? You only look at your x values, right? So this is 0. So that you have your x-intercept at 0, 0, and then this is basically going to be -6, right? So you do have your x-intercepts at 2 points, so it's not just one x-intercept, so it's 2 for number 1. That's why it doesn't make number 1 an option. Okay, so maybe we can move on to option 2. So for option 2, you have f of x, and this is equal to 2x, and this is times x minus 6. So right off the bat, you can see that one of your x's is going to be 0, so that's 2x, so that's 0. And then for here, you have x minus 6, which is just going to be positive 6, right? So that's why you have two x-intercepts, and it's actually found at positive 6 and 0, right? Not at -6. And then if you take a look at number 4, right? So this is f of x, which is equal to x squared plus 3x plus 2, right? If you try to factor this, right? So maybe we can have 2 and 1. Okay. Yeah, it's either you apply the quadratic formula or you think of two factors that you can multiply to. Yeah, two factors that you can multiply. However, when you add them together, you get 3. So if you have 2 and 1, that's going to work. So if you have, let's see, positive 2 and positive 1, this might work. So yeah, all you do, right, just to double check, is to expand. So you have x squared, and this is just going to be plus x, then this is plus 2x, and this is plus 3. Or actually, sorry, plus 2, right? So apply FOIL method to double check that this is your quadratic equation. So this is x squared, then you have plus x, and this is plus 2x, and this is plus 2, not plus 3. And then finally, we can add the 2, right? So this is 3x, and this is plus 2, and this is x squared. So yeah, this is, in fact, your factored form of x squared plus 3x plus 2. That's why your x-intercepts are going to be at -2 and -1. So it's not at -6. That's why it's not option 4. So yeah, the correct answer is only going to be option 3 because they're looking for because they're looking for one x-intercept at -6, 0. Okay, I don't really know what's wrong with me today. I apologize. Okay, so -6, 0. So option 3 is correct. Great. Okay, great. Okay, I have no idea what exactly this question means, but based on the solution that they presented, I think they wanted you to convert 45 degrees Celsius to Fahrenheit. So yeah, so here it says the Celsius and the Fahrenheit are two important scales that are commonly used to measure temperature, and the formula to convert Celsius to Fahrenheit is, there we go. Okay, so we have degrees Fahrenheit, which is equal to, okay, so they're trying to say that there's two formulas that you can pick. So the first one, let me just see if 9 divided by 5. Yeah, okay, so 9 divided by 5 is equal to 1.8. So they're giving you two options. It's either you use this formula or this formula, but the whole point of this formula is you have Fahrenheit and you have degrees Celsius, right? So if you do have degrees Celsius, which is what they have shown us, right? So you have 45 degrees Celsius, you need to convert this into Fahrenheit. So you can actually use any of this formula. So maybe we can just use the one that's presented. So the first one, actually let's use the two, right? But they're both equally acceptable, so you can pick any of this. So you have 45 degrees Celsius. You need to convert this into Fahrenheit. So according to the formula, you have Fahrenheit, which is equal to 45, right, degrees Celsius. So let me just drop the units for a second, and then you have 9 over 5, and this is basically plus 32. So as you can see, you need to multiply 45 times 9 over 5. You can simplify this with 9, right? because 45 and you have 5, 45 divided by 5 is going to be 9, so 9 times 9 is going to be 81, and this is plus 32, right? So you're going to see that this is 113 Fahrenheit, degrees Fahrenheit. So that's why, and they're supposed to be degrees Fahrenheit. Okay, great. So that's why your final answer is 113 degrees Fahrenheit. And if you were to use the formula that has 1.8 as opposed to 9 over 5, so you're going to have Fahrenheit, which is equal to still 45, right? And this is times 1.8, because we know that 1.8 is equal to 9 over 5, and this is plus 32. Then all you have to do is multiply 45 times 1.8. So this is going to be 81, right? And just so you know, how can you multiply a whole number and a decimal number, just so you're wondering. So let's do that, right? So this is solving a whole number and a decimal number manually. So all you have to do is you multiply this first, right? Because you always start from right to left when you're trying to multiply numbers manually. So you would have 5 times 8, which is 40. And then you would have 4 times 8, which is 48. And basically 4 times 8, so that's, did I just say 48? Okay, sorry. 4 times 8 is 32. Okay, 6 times 8 is 48. Sorry. Okay, so 4 times 8 is 32. And then you add that to 4. So this is 36. Okay, great. I've just had that moment. So anyways, yeah, let's get back to this. So 5 times 8 is 40, and then you have 4 times 8, that's 32, plus 4, that's 36. 5 times 1 is 5, and then you have 4 times 1, which is 4. Okay, and as you can see, you leave a space here because when you're trying to multiply and you move on to your next decimal place value, you leave this blank. And then this is basically going to become 0, right? So 0 plus 0 is just going to be 0. Then you have 6 plus 5, which is 11. Then you have 1 plus 3, which is 4. 4 plus 4 is 8. And then as you can see, because you have one number after the decimal point, that means you start from this 0, right? Don't forget you still have that 0, right? Don't just drop that and have 81, because that would be wrong. And then all you have to do is you move this decimal point to the left once, because you only have one number after the decimal point. That's why you're going to get 81. So this is 81 plus 32, and this is equal to 113, and this is degrees Fahrenheit. So that's your final answer. Okay, yeah, just so you're interested in terms of how you want to multiply numbers with a decimal number, and if you forgot about doing that manually, so this is a quick refresher. Okay, great. Solution is correct. Okay, so I guess we've reached, yeah, that was the last question, I guess. So I just want you to think about the questions that we've done so far, and hopefully at the end of this class you do have a better understanding of the popular questions from homework help. I know this is a stressful time for everyone just because every single class right now is being switched online, and the last thing you probably want is having another class online. But again, I think you need to have that mindset that at the end of the day you're going to be back to your regular classes, right? Hopefully once this is over, and you want to stay on top of your studies. You want to get ahead as much as you can and stay as productive as you can during this learn at home season. So yeah, more power to you. Once again, this is Janine the Tutor, and I'll see you on my next class. Bye guys.